find P if 451 to the base 6 negative P to the base 7 equals 305 to the base 6. Now the options you're given is 611 to the base 7, 142 to the base 7, 116 to the base 7, and 62 to the base 7. So there are different techniques you could go about in solving this problem here. But the thing is, our aim is we intend to solve this problem using the quickest means, because you'll be timed in the exam hall. So we need the quickest means to find the solution to the problem. Now what you observe is that the equation we have here is a heterogeneous equation. In other words, all the base that is the basis of all the numbers we have here, they are different. For example, the first number you have here, 451, has a base of 6. The next number has a base of 7, while the next number has a base of 6. So they all have different bases, and we intend to find P. So the best technique I think you should do here is convert all the terms of this equation, convert them to base 10. So convert to base 10. Now when you convert to base 10, you find P. But then our aim is that the P that we're told to find has to be in its original base, that it has to be in base 7. So the technique we're going to do here is we're going to convert all the terms here to base 10. We find P. So since we want to find P in its original base, so whatever we obtain, we'll convert it back to base 7, and then we choose our answer from the options that we are given. Alright, let's start. So we're given is 451 to the base 6 negative, so we have here is P to the base 7, P to the base 7, so this equals 305 to the base 6. So my aim is I'm going to start by changing. I want to convert 451 to the base 6 to base 10, P to the base 7 to base 10, and 305 to the base 6. I'm going to convert that also to base 10. So let's see how I do that. So what I have is 451 to the base 6. So to convert this to base 10, so what do? Well, the best thing you can do is all the digits you have here. So you begin by labeling the first one. You call this 0, you label this 1, and then you go 2. So you start from the right hand side up to the left, and you move on to following the left orientation here. So and the number you start with is 0. So do not start with 1. You start with 0, 1, 2. So the next thing we do is to convert this to base 10. This is going to be 4 times, now the base you have, which is 6, this is going to be 6, now raised to the power 2. So what you have here is 2. And then you close bracket, then plus, so the next number you have is 5 times, so the base we have is 6, so you write 6, then the power you have here is 1, so we write 1. You can see the power you have here is 2, you write 2, the power you have here is 1, so it's 5 times 6 to the power 1, and then we close bracket, so we have this, then plus the last one, so you can guess that's going to be 1 times, so what you have here is 6, so you write 6, then you close bracket, sorry, and what you have here is 0, so you write 0 here, so it's going to be 0, sorry, this should be 0, it should be 0, so we don't confuse things here, and then we close bracket. So this is just going to give you 4 times, now 6 squared is going to give you 36, plus 5 times 6 to the power 1 is going to give you 6, plus 1 times 6 to the power 0 would give you 1. Now 4 times 36 is going to give you 144, plus 5 times 6, which is 30, plus 1. Then 144 plus 30 plus 1, that's just going to give you 175. So this is 175 in base 10. But by convention, we usually don't write the base whenever it's in base 10. So this is just 175. So we don't have to write the base. Just by convention, we don't have to write the base. But you could write it if you like. So now we've converted 451 to base 6 to base 10. So let's go ahead and convert p to the base 7 to base 10. So we have p to the base of 7. So we want to convert this to base 10. So how do we do this? So the thing you do is, so like we said, we always start with 0. So we start with 0. So what you do here is to convert this to base 10. So like we did here, what you have here, you write p times, so what you have is the base is 7 and the power here is 0. So this is the only number we have here. So this is just going to be p times 7 to the power 0 is 1, and that's just going to give you p. So we could just run along and do the same thing for 305 to the base 6. So for 305 to the base 6, that's just going to be 305 to the base 6 to the base 6. So you could just begin by labeling them. So let's just call this 0, like we said, 1 and 2. So this becomes 3 times, so you have 6 to the power 2, so you have 6, then the power here is 2, so you write 2, then you close that, plus, so 0 times 6 to the power 1, that would be 0 times 6 to the power 1, so you close that, then plus 5 times 6 to the power 0, that is 5 times the base, which is 6, and the power you have is 0. So you have this, so you can close the bracket. So this becomes 3 times 36 plus 0 times 6 to the power 1 is 6, plus 5 times 6 to the power 0 is 1. Now 3 times 36 is 108, plus 0 times this is going to give you 0, plus 5 times 1 is going to give you 5. So 108 plus 5 is giving you 113. So in other words, I can rewrite this now as this. So 451 to the base 6, we obtained it as 175. So what I have is 175 to the base 10 minus, so p to the base 7, we obtain that as p. So minus p equals 305 to the base 6 has been obtained as 113. So this is 113. So to find p, we could deduct both sides. We could subtract 175 from both sides. From both sides, you have negative 175, negative 175. And when you do that, so this goes off. So you'll be left with negative p equals 113 negative 175 is going to give you negative 62. So to find p, we divide both sides by negative 1 by negative 1. So this goes off and then this goes off. So we have p to be equal to 62. So you note the answer we obtained here is in base 10. But when you look at the original equation, the base here is 7. So I need to convert p in base 10 back to base 7. So I need to convert back to base 7. Now how do I convert 62 in base 10 to base 7? Now this is what you do. So the 62 you have, let's write that down. You have 62, then you begin to divide by 7, and then all we need to take into consideration is just the remainder after you divide each of the quotients we obtained by 7. So the divisor is going to be 7, since we want to convert to base 7. So you write 7 here. So since you're converting to base 7. So if you want to convert to base 5, you would write 5. If you want to convert to base 4, you'd have written 4. So since we are converting to base 7, we write 7. Now 7 in 62, or 62 divided by 7, is going to give you 8, remainder 6. So again, we keep on dividing. You have 7 divided 7 in 8 is going to give you 1, remainder 1. And then at the last stage, so what we say is 7 in 1, this is just going to give you 0, remainder 0 remainder 1. This is just a conventional way of rounding it up. Anytime you have 1, you always have 7 in 1. Since it's not possible, you write 0, so remainder 1. It has no quotient. So to find the conversion from 62 to base 7, we read the remainder from down up. So read from down up. So when you read that, you have 116. That is 11116. So this is just our final answers. 116 to base 7. So 62 in base 10, when you convert it to base 7, you have 116 to base 7. So let's check our answer. Yeah, here it is. 116 to base 7. Yep.